Okay, we'll do this with the calculator and we'll do this with the table. So in A, you're getting the critical value for 95% confidence interval, degrees of freedom 7. So let's look at the table. Degrees of freedom are 7. A 95% confidence interval is in the middle column here, and that corresponds to a one-tail probability of 0.025 or a two-tail probability of 0.05. So, so 7. Let's go back. I want to go back to the question real quick. Is it sample size 7, degrees of freedom 7? I think it's sample size 7. Yeah, degrees of freedom are 7. So we'll go back to here. All right, so degrees of freedom right here, 7. And we go over to 0.05, which corresponds to 95%. And the critical value is 2.365. So in other words, the z-star is 2.365. You need 2.365 standard deviations in order to get to a 95% confidence interval. The 0.05 for the two-tailed probability corresponds to 95%. Okay, so 7, 0.05, 2.365. Okay, back to the question. B, critical value for 99%. Now, degrees of freedom with 102. This is harder to get from the table. You have to just sort of guess it. Okay, so 99%. We don't really have 99% here. Now, it's on the other table. I'll show you on the other table. Okay, now 102 degrees of freedom. Well, here's 100. Now, if you notice, the numbers for 100 and 120 are hardly any different, so we'll just use the ones for 100. And we have, let's go back to the question. It's 99%. Okay, so here's 99%, and here's 100 right here. Now, it says 102, but you can see there's only a difference of a few thousandths between these two numbers. So we're just going to call it, you could round it up to I wouldn't call it 2.63 if you wanted to. But that would be definitely close enough. Okay. So doesn't have a 102, so you have to round up a little bit. All right. Back to the next question. The p-value for t is less than 2.19 with 41 degrees of freedom. Okay, now you can get this from the table as well, or you can get it from your calculator. This we'll get from the calculator since you have TCDF. And getting it from the table is a little more complicated. So we'll do second and vars, and we're going to do TCDF number 6. Now this is kind of weird, less than 2.9, so we're actually going to do negative 99, comma, normally you would do this, I don't know, put it this way to try and trip you up or something. 2.19, comma, and then 41 degrees of freedom, 41, that would be for sample size of 42. And you can see it's almost everything under the curve. Okay, p-value for the absolute value of t greater than 2.33. That means they want you to go from second vars. Okay, TCDF 6, and that would be from negative 2.33 to positive 2.33, comma, 12 degrees of freedom. And so that's 96%. So with about 2% in each tail. Okay, now if you have inverse t, let's do A and B using inverse t. And that's going to be second in vars and then inverse t number 4. Okay, now inverse t goes from 0 all the way to the left-hand tail to the right. Okay, so we want a 95% confidence interval. So that means we want to go to the end of the tail. We want to go all the way to the tail that's left by 95% confidence interval, which is 2.5%. So we're going to go to 0.975. That's 1 minus 9.95 divided by 2. Take that difference, add it to 0.95, you get 0.975. Okay, so inverse t, 0.975, and then we're going to put in the degrees of freedom, number 7. And it's, notice we said it was 2.365 from the table, and you got more, obviously you're going to have a little bit more refinement when you use the calculator. Now, 99% confidence interval, we're going to get definitely more accuracy here. Let's do second and vars, because the table doesn't have degrees of freedom for 102, it just had 100. So we'll do inverse t, number 4. So we'll put in 0.995, in other words, half of 1%, add it to 0.99, comma 102, and we hit enter, and we get point. Now notice we said we should round it to 0.263, which we almost could do. This I'd call this point 2.625. So 2.63 would definitely be good enough. That's it.